everyone. I hope you had a nice weekend. So I'm going to continue with inequalities, and I have pre-prepared my number lines to hopefully save a bit of time. Okay, so I'm going to go through these and then we'll go in and actually solve some problems. So, like with all of these, you need to translate them. Okay, so we need to read it and translate it. So I'm going to write it down just, because we're still learning this. But the first one says x is less than or equal to 3, and it says that it has to be natural. Yeah. Okay, so less than or equal to 3. The fact that we're going less than is to the left. Okay, so that means I'm going to put my 3 on the right. Does that make sense? So the numbers I'm concerned about, the x numbers, are less than 3. So I'm going to put my 3 on the right hand side so that I can move to the left because that's the less than side. Okay, so I'm going to put my 3 over here. I'm going to work down less than, so 2, 1, 0. I'm going to fill the space I have. Yeah. Okay, so less than or equal to 3, which means 3 is an option. So I can put my dot on 3. Less than 3, I go to 2, I go to 1. Now, so 0 is clearly less than 3, but is it natural? It's not, okay? So I'm not going to include 0. Minus 1 is the same. It is less than 3, but it's not natural. So none of those are going to be included. Okay, so there's no need for an arrow here because we're talking about less than 3. So it can't be on the right hand side. It can't be over here because we're not going in that direction. We're going in this direction. And it can't be any smaller than 1 because it's a natural number, so it can't be 0. So the last question we need to ask ourselves is whether or not we need to shade in the line. And because it's natural is only whole numbers, so we don't shade in the line. So that's my number line. It's the number 1, 2, and 3. Yeah? Okay. The translate first. So x is greater than or equal to minus 5, and it's integer. Okay, so greater than minus 5, so that means when you're doing greater than, you're going to start on the left and move to the right, because that moving to the right is the number line getting greater. So that means I'm going to take my minus 5 and I'm going to put it way over here. I'm going to move to the right. So minus 4, minus 3, it's actually going to look exactly like the one above, strangely enough. Sorry. So go back to the minus 5. Is that part of the answer? The question says it's greater than or equal to. So the fact that it says or equal to means I can include the minus 5. Greater than minus 5 then is minus 4, minus 3, minus 2, minus 1, 0. So all of these are integers. We don't have the problem we had the last time. So 1, 2, 3, all greater than minus 5. And this time we could continue. So 4, 5, 6, 7 would all work. And then do we shade in the line? We don't because they're integers and integers are whole numbers. So that's that one. Okay. The third one. Translate x is greater than, I'll scroll down now, or equal to minus 1, and these are real. So greater than or equal to -1 and real is what this one says. Okay, so again, if I'm going to do greater than, it means I'm going to be moving to the right. So I'm going to put my -1 over here on the left, and I'm going to move to the right. So these are numbers greater than -1, which is 0, 1, 2, 3, 4, 5, 6. I'm just going to fill the space. It doesn't matter how many. I happen to have 9 sections on mine. It doesn't matter. Okay, so again, the or equal to is important because it means I do in fact include the -1. I also include the numbers greater than -1, 0, 1, 2, 3, 4, 5, 6, and 7. Could it continue? Yes, it could. So I need an arrow there for it to continue. And then do I shade in between? So this set is real numbers, and real numbers does include fractions and decimals. So I do have to, I'm actually just going to do this with a really thick line. Hang on, just save me. So there you go. So it's not just the whole numbers, it's all the numbers. Okay, D we can just about see there. So X is less than -4, and it's an integer. Okay, less than -4 and it's an integer. Okay, so this time I'm doing less than. So I'm going to be moving left. So I'm going to put my -4 over here. Oh, sorry. I'm going to put my -4 over here, and I'm going to go less than -4. So less than -4 is -5, -6, -7, -8, -9, -10, -11, -12. Yeah? So notice this time there is no or equal to, which means I'm not going to put a dot on the -4. I'm going to put my first dot on the -5. -6, -7, -8, -9, -10, -11, -12. It would continue, so we stick our arrow in, saying that it could go smaller. And then do we shade in? It's an integer, and integers are whole numbers, so no. Okay? Right, so I'm just going to scroll down. I'll write and then I'll bring you down to it. So translating E, X is less than 5, and it's real. X is less than 5 and it's real. Okay? So again, if I'm going to go less than, it means I'm going to be moving to the left. So I'm going to put the 5 on the right, and I'm going to write down numbers that are less than 5. So that's 4, 3, 2, 1, 0, -1, -2, -3. Same as in D, there's no or equal to. So I'm not going to put a dot on 5. I'm going to put my first dot on 4, and then 3, 2, 1, 0, -1, -2, -3, and it can go on. So I put my arrow down. So do I shade? It's real, and real includes everything. So yes, I am going to shade. But remember, when we say X is less than 5 and it's real, it goes all the way up to 4.99999. So I did show you an example of this. We say that 5 is not included. Okay, 5 is definitely not part of it, but everything right up to 4.999 is included. Yeah? Okay, and the last one, translate. X is less than 2, and it's natural. So again, if we're going to do less than 2, it means we're going to be moving to the left. So I'm going to put the 2 on the right and go smaller than 2. And again, just fill the number line. Okay. There's no or equal to, so my first dot's going to go on 1. Now, my next dot would go on 0, except that this is the natural number set. and none of these numbers are natural. So that is your number line. It is literally just the number 1. Okay, so they can't be sorry, they can't be like, they have to be perfect. So you have to have the dots in the right places, the arrows in the right places. You know, the only difference between your number lines and my number lines is that yours might not necessarily have as many numbers. So if I started, I don't know, for example, in D, I started on the right with -4, and then I went -5, -6, -7. You might only have done to -8. But other than that, your number line should match mine perfectly. You should have the dots, you should have the arrows pointing in the right direction, -1 with no dot in it, etc., etc. Okay, so there's quite a lot. These are hard. There's quite a lot of learning in those. So make sure you understand those. And if you don't, you can ask me next class. I should be back. Okay, so let's look at solving inequalities. This is actually easier than the number lines. Okay, so we'll have a look here. Now we're still in the ordinary level chapter, but there's not a huge difference. There's only things they're called compound inequalities in the higher level chapter, and that's pretty much the only difference between ordinary and higher. Okay, so solve the following inequality and show the solution set on a number line. So like I said, you need to be able to do the number line. You'll always be asked. Okay, so 2x less than or equal to 8. This we need for the number line. It's not part of the solving. It's part of the number line part, so we don't need it for this bit. Now, you treat inequalities almost, and the almost is important, but I'm going to write it. Okay, so they're almost exactly like regular equations. I'm going to show you the almost bit, but if this was a regular equation, we would want to isolate the x. How do we isolate the x? We divide by 2. If you divide by 2 on the left, you have to divide by 2 on the right. So we get x less than or equal to, and 8 divided by 2 is 4. Yeah? I'm going to throw down a number line. There's my number line. Again, I'm not really concerned with how long it is. I'm just going to give myself 3, 4, 5, 6, 7, 8, 9. Okay, so this translates to x is less than or equal to 4. And if you remember from up above, we're talking about integers. Okay, so if we're doing less than 4, it means we're going to be moving to the left. So we're going to put the 4 on the right. So I go 4 and I do numbers less than 4 until I've completed my number line. Okay, it does have or equal to, so I will include the 4, and then numbers less than 4. I'm always wary going from 1 into 0 in case it's natural, but this isn't natural, it's integers, so I can keep going. So 0, -1, 2, -1, -2, -3, -4, and an arrow because it can continue. And do I shade in? No, because they're integers and integers are whole numbers. So that's that. Okay, so we'll do this one, and the next day I'll show you the almost stuff, just because it's kind of an important one and I'd prefer to be there to show you. So we have 3x plus 7 less than 22, and again this will be our number line bit. So here is the thing I'm trying to isolate. So we will have to minus the 7 to cancel the plus 7, and we'll have to minus the 7 to balance it out on the far side. So now we have 3x. Just be very, very careful. It's really easy to write an equals out of habit. So make sure you copy your sign. Okay, so it's not an equals, it's an inequality, and make sure you copy it. 22 minus 7 is 15. And then we have divided by 3, divided by 3. So x is less than 5. Okay, so again, I'm going to throw in my little number line, because as always, you have to display your answer on a number line. Just put in my marks. Okay, so translate. X is less than 5, and from up above, it's natural. Less than 5 means I'm going to be moving to the left, so I'm going to put the 5 on the right, and then 4, 3, 2, 1, 0, minus 1, minus 2. There is no or equal to, so I'm not going to include the 5. I'm going to start on the 4, and then 3, and 2, and 1. And again, I'm always conscious going from 1 to 0 in case it's natural. And in this case, it is natural. So we can't go into the 0 and the negative numbers. Because it's natural, they're whole, so I don't shade in. So I'm finished. Okay, so hopefully you can see by those examples that solving inequalities is very, very similar to solving regular equations. There is a difference, okay, and the difference is when you have a minus. And I'm going to go through that on Thursday. But that's why I have the big almost up here. Like your process, everything I taught you when you were doing regular equations is the exact same. Just be really, really careful that because you're using that process, sometimes students, they stop writing the inequality and they start writing an equals. So just be really cautious that you keep the inequality. And I will, I'll do the negative issue with you, the only difference between inequalities and equations, on Thursday. Okay, so your homework, I'm just going to make sure I pick correct ones. Let's do, right, sorry, I'm going to highlight all of these. I'm not giving you all of those. I'm just going to do it with the pen. So, what is it? Monday, the 10th, is that right? Okay. So, I'm just going to pick out a couple of these. So let's do 8, 9, 12, 13. Yeah, those 4. Okay, so you need to solve them, and then you need to put them on a number line. Okay, each one, you're told which set it comes from. So those 4 questions for homework, please. Okay, and hopefully I'll see you on Thursday.